Okay, today we're going to be talking about 4.7 fractions and decimals. There's two vocab words that I want you to go ahead and write down for me, please. Write down the definition for terminating and repeating decimals. The first one is a terminating decimal. How many of you have ever heard of someone's job terminating before? It means it came to an end, okay? Either the company closed, so they didn't have a job anymore, or the person was let go, so their job was terminated. In any case, terminating means a decimal that ends. So here we have 4.75. You can see it ends right after the 5. You could have 5.1, 6.2. Who can give me another example of a terminating decimal? Carlos?
100.2.
100.2, okay? That's a fever you don't want to have. All right, who has got one more? Katie? 89.1. It ended, okay? Let's look at the next one. It says a repeating decimal. This is a decimal with one or more digits that repeats. 1.363636. Really, this means it would continue to go on forever and ever and ever, okay? You could have 4.33333333. Because it repeats, it's called a repeating decimal, okay? So today we're going to be talking about terminating decimals and repeating decimals. Right. Number 1 says, write the fraction or mixed number as a decimal and tell whether the decimal is a terminating decimal or a repeating decimal. The first one says 7/20ths. Anytime you see a fraction bar, what sign does that mean?
Division.
Division, okay? So I'm going to write the 7 divided by 20. All right, can a 20 fit into a 7? No, it can't. So who can tell me what I need to do?
Add a decimal.
Add a decimal and?
0 and 2 zeros.
Okay, we're going to actually add 3 zeros just in case. You don't always need all 3, and sometimes you might need more. So the first thing you're going to do is bring that decimal point up. How many times can a 20 fit into a 7?
3.
How many times can a 20 fit into a 7?
0.
0 times. It cannot fit into it. Can a 20 fit into a 70?
Yes.
Yes, how many times?
3.
3. Okay, 3 times 20 is 60. What's 70 minus 60?
10.
10. All right, so now we're going to do what?
Bring down 0.
Bring down another 0. Okay, how many times can a 20 fit into a 100?
5.
5 times. What's 5 times 20? 100. Okay, and 100 minus 100? 0. Anytime that you get to a 0 down there at the bottom, that means you're finished. Okay, so we really did not need that extra 0 that we had brought right there. So what's my final answer, guys?
0.35.
Okay, you can either do it as 0.35 or 0.35. It means the same exact thing. All right, so now what I want you guys to do is pull out your calculators for me. And I want you to put in your calculator 7 divided by 20. When you guys put that in there, what do you get?
0.35.
Okay, 0.35, all right, or 0.35. On your homework tonight, you do not have to show me all of this work, but I wanted you to know exactly how we're getting that answer, okay? So let's go ahead and do the next one. For the next one, 3 and 5/8. This one looks different than the first one. How does it look different? It's a mixed number. So before you can do anything, you need to turn this into an improper fraction. Raise your hand if you remember how to do that. Michael, what do I do?
8 times 3 plus 5.
Okay, 8 times 3 is what?
24.
24, and then plus 5 is what?
29.
Okay, so what's my answer?
29.
Okay, 29/8. Now, if you wanted to, you can definitely do 29 divided by 8, or you can just put it into your calculator and see what it would come out as a decimal. Kyla, what did you get? 3.625. Okay, now it has asked us to do one more thing for each of these. It says to tell whether the decimal is a terminating decimal or a repeating decimal. So let's go ahead and look at example A. 0.35. Is that terminating or is that repeating?
Terminating.
It's terminating. It ended. It did not go 0.35353535, okay? If it had continued repeating the numbers, it would have been repeating, but it did not continue repeating. Therefore, it's terminating. It ended. Let's look at the next one. Jakari, 3.625. Is that terminating or is it repeating?
Terminating.
It is also a terminating decimal because it ended. Okay, once again, I'm going to give you kind of an example. If you had seen it say 3.625 and then it never ended and it just kept going, that would be a repeating decimal. All right, number 2 says to rewrite the repeating decimal using bar notation. How many of you would say you remember how to do this from last year? Give me your best guess. Instead of writing 0.393939, what could I write instead?
0.39 with the line over.
Okay, 0.39. And should I put my bar over the entire thing? No. What do you put it over?
Over the 39.
Only the thing that's repeating. The 39 was repeating, so we only put it over that. Okay, who would like to do problem B? Katie, go ahead.
B is going to be, you're going to have you're going to do 1.7 and then put the bar over the 7.
Okay, and the bar goes over the 7.
Only the 7.
All right, so that is how you put something using bar notation. You could continue to write 1.77777777. It would go on and on forever, or you can just do 1.7. You simply put the bar over the numbers that repeat multiple times. Number 3 says write the decimal as a fraction or a mixed number. Can someone tell me, instead of just reading this as 0.85, does anyone know how to read that in a different way? How would you read it? 85 hundredths is exactly what that would be, okay? There are 0 whole numbers, but you can see this is the tenths place and this is the hundredths place, all right? So because of that, it's 0 and 85 hundredths. Okay, now remember, we always put things in simplest form. So what number can go into an 85 that can also go into a 100?
5.
A 5. Okay, you can choose that every time because it ends in a 5 and a 0, and we always know that a 5 can go into anything that's a 5 or a 0. So you're going to divide by 5 on top, and then you've also got to divide by 5 on bottom. Put that in your calculator. When you do it, what do you get?
17 over 20.
17 over 20. So that is how you write 0.85 as a fraction. Moving on to problem B, a lot of times when we look at it, we say 4.375. How would I read that the correct way?
375 thousandths.
Okay, 4 and 375 thousandths. Okay, so if you notice right here, there's 3 numbers after the decimal point. You have 3 zeros. Here you have 2 numbers after the decimal point, and then you have 2 zeros. Okay, so that's just to kind of help you with what place it is that you're talking about. Now, do you think that that is reduced as low as it can go?
Nope.
What can go into both of those numbers?
5.
Something bigger than a 5. Not a 10.
15.
Nope.
25.
A 25. Okay, so let's divide by 25 on top and divide by 25 on bottom. What do you get?
15 over
15 and over 40. Don't forget about your whole number, that 4 right there. You want to bring that over too. So you've got 4 and 15 40ths. Is 15 40ths as reduced as it will go? No, what can go into a 15 that can also go into a 40? A 5. So divide by 5 on top and bottom. And what is your final answer? 4 and 3/8. Okay, once again, thank you for telling me about the whole number there, okay? So if you had a whole number here, you want to make sure you also have your whole number there. And then basically, 0.375 is the same thing as 3/8, okay? So your answer is 4 and 3/8. Always make sure whenever you have a problem that looks like this that you reduce and you put things into simplest terms. All right, so those first 3 examples are going to help you with your homework tonight. I want to go over some review problems. This is a problem that we did at the beginning of the year. So go ahead and write this down. Write the number in standard form. I want you guys to try and see if you can figure it out on your own. All right, does anyone think they remember what it is?
Yes.
Who wants to help me with how to do it? What should I do?
Oh, wait, no, actually, no, because I don't know.
Help me out.
5. Okay, so we're bring 5.35 down.
Okay, bring this part down. Then what?
We're gonna bring it over 3 times.
Okay, because it says 10 to the third, that tells me I have to move the decimal 3 places. 1, 2, 3. Then what?
Drop it down.
Drop everything down.
And put your comma behind the 5.
Put your comma in. What's my answer?
5,358.
5,358. Good job remembering that.
Yeah, I did not.
Number 5 says to write the number in scientific notation. Tell me, guys, where is the decimal point on this number?
At 1 0.
At the end. I have to move it to where there's only one number in front of the decimal point. If you look, there are 3 6 numbers to the left of the decimal point. So I've got to move it until there's only one number in front of it. So now I've moved my decimal point there. What do I do now?
Drop it down.
Drop down all of the numbers except for which number?
The 0.
You never bring down those zeros. Remember we talked about it, those zeros float away into outer space and they're gone. Okay? So, am I done?
No.
No.
You gotta say, I mean,
Scientific notation, you always multiply by the number what?
10.
Times the number 10, and then you have to count how many times you moved your decimal point. So count with me, how many times? 1, 2, 3, 4, 5. All right, so what is the answer?
3.7743 times 10 to the 5th power.
Times 10 to the 5th power. Number 6 is asking us to copy and complete the statement using less than, greater than, or equal to. The problem is these guys don't have a common denominator, so it's very tough to compare them. So let's see if we can find a common denominator. Can a 9 go into a 12? No. All right, so we're going to have to go ahead and do the next multiple. What's the next multiple of a 12? 24. Can a 9 go into a 24?
No.
No, it cannot. What's the next multiple? 36. Can a 9 go into a 36? Yes, then I know that is my common denominator. So directly underneath it, go ahead and write 36 for both of them. But now we've got to figure out, how do I get to a 36? How do I get from a 9 to a 36? Multiply by 4. So if I multiply by 4, and I want to see this work, you guys must show me this work. If I multiply by 4 on the bottom, what do I do to the top?
Multiply by 1.
Also multiply by 4. So now we know 9 times 4, you can see, is 36. What would 6 times 4 be? 24. So you've just figured out this is an equivalent fraction, all right? 6/9 is the same thing as 24/36. Who can do the next one for me? Let me have Jakari. How do I get from a 12 to a 36? Not multiplied by 4. 12 times 4 would be 48. Times 3. JD, what would my new equivalent fraction be? 636. So now I can easily see 24/36, 6/36. What should go in the middle of those two? 24/36 is...
Small. Greater.
Is it greater or less or equal to?
Greater.
24/36 is greater than 6/36. It's pretty simple, guys. A 24 is bigger than a 6. Okay? So then that means 6/9 is greater than 2/12. This is asking us to order the fractions from least to greatest. We are going to do very similarly to what we just did. Before we only had 2 fractions we were comparing. Now we've got 4. So what do I have to do before I do anything else? Find the common denominator. So let's look at what the biggest denominator is there. Which one's the biggest? 12. Can a 6 fit into a 12? What about a 3? What about a 4? Okay, so I'm just going to be able to use the 12. So directly underneath each one of these fractions, go ahead and put a 12, because that's what we are going to be making equivalent fractions, but they will have a 12 as their denominator. Landon, first up, I've got 4/6. What do I have to multiply by to get 12ths? Multiply by 2 on bottom and 2 on top, and what do you get? 8/12 is correct. Next up, Gabby, 1/3. What do I have to multiply that 3 by to get a 12 in the denominator? Times 4 on top and bottom, and what's my new fraction? 4/12 is correct. Next up, Carlos, 3/4. What do I have to multiply by to get to a 12ths? Times 3 on top and 3 on bottom, and what do you get? Not 6.
Oh, no.
3 times 3 is 9. Excellent job. Alex, 2/12. What do I have to do to get it to turn into 12ths? Just keep it right there, okay? You could put in there times 1, but it's really not necessary because you're just rewriting the same thing. Now I've got to put them in order from least to greatest. Kyla, what's my tiniest one? 2/12, okay? So let's go ahead and write that down. We're going to cross those out. Next up, Michael, what is the next tiniest one?
The next tiniest one is 1/3.
Okay, it is 1/3, all right? We knew it was 4/12, but he's writing it as the original form, 1/3. Next up, Katie.
is 3/4.
It's not 3/4. Look down here at what's left down here. What's smaller, 8/12 or 9/12?
8/12.
8/12. So what's the original for 8/12?
4/6.
4/6 is what I'm going to write. Isabel, what's my final one? Okay, it was 9/12, so that is 3/4. And this is how you put them in order from least to greatest. Write the mixed number as an improper fraction. We've got 5 and 2/8. What do I have to do first, guys?
5 times 8.
You do 5 times 8, and what do you get? 40. And then what do you do?
Plus 2.
Plus 2, so what's your answer?
42/8.
42/8. All right, so those are just a few review problems. This is tonight's homework. Once again, it's just 10 problems, so I want you guys to go ahead and label your paper for your homework tonight.